Good morning. I'm speaking with Steve Davies. He's the Vice President of the Packaging at NatureWorks, and I'm speaking to him here at the at the European Bioplastics Conference in Berlin.
17th annual, right here in Berlin, yeah.
That's it. Right, Steve. NatureWorks has been pretty active despite the fact that we've all been in a pandemic. You guys have moved, built a new plant. You've been doing everything. Tell me, can you talk about your partnership with CJ Bio, the producers of PHA, because that's a totally different bioplastic. So how does that work?
Yeah, for us it was a partnership long in the making, and happy to be able to pull it off even from behind our desks during COVID, which is no mean feat. I'll be moving actually from here to Korea to talk finally in person with some of the principals, which we look forward to in person. But the genesis was simple in that when we built our Ingeo polymer platform, biomaterials platform, while we may be asset invested in PLA, that was never the intent that we limit what we put into the market to one material only. And so we've long looked at what can we put with it, whether it's the PBATs, PBSs, PCLs, so that an Ingeo grade going forward is going to be basically whatever it needs to be to give the right performance criteria. And now we can add to our portfolio a particular PHA. And over longer term, as CJ commercialize more PHAs, because they have the whole metabolics portfolio, we have access to any and all of those. That's what's exciting to us.
Okay, that sounds really exciting indeed. And did it make a difference that it was amorphous PHA? Was that something specifically you were looking at?
It was a very good starting point for us, and one of the things we liked was the reality that CJ brought to the picture. As they purchased the metabolics portfolio, we thought they were very realistic in what they started with, which was a material designed to be used in, say, 5, 10, 20% concentrations as a rubber modifier to a hard, rigid material, which the PLAs are. And so with it, and I showed a schematic yesterday, with small amounts of this rubber modifier, fully bio-based and degradable, so very compatible with what we do, we can really move our properties around across the sort of hard, rigid to soft, flexible space, from sort of the PET, polystyrene space to the polyolefin space. We can now span that.
Right, so it really increases your versatility.
Exactly.
Right. Okay, and you also had the exciting news that you're actually really starting to build your new plant now. Why Thailand?
It's many reasons. Some obvious ones, and when we've looked for many years at where to put things, and it was basically sort of aligning three things. We said this back in 2010, and there's still the right three things. Where's the raw material in abundance? Where's the customer base? And where do the incentives align? And those all come together beautifully in Thailand. Thailand still the world's second biggest exporter of sugar. The Thai government eager to bring green industry to Thailand and export something more value added than an ag commodity, sugar. We have a Thai owner who's really helped facilitate the process. And so all of those things come together with a growing and vibrant Asia Pacific customer base that we'd love to be able to supply locally and more responsively. So everything makes sense for us.
Yeah. And you mentioned it was going to be an integrated plant.
Exactly. Yeah.
What do you mean exactly by integrated?
We like to say sugar forward, meaning that we will buy sugar. We are building and will run the fermentation site to ferment sugar to lactic acid. That's what we call plant 1. The second plant will be a plant to go from lactic acid to lactide, which is the actual building block we use to polymerize to polylactide. So those three plants will be right next to each other, supplying each other. Different than our current facility in Nebraska, where we don't own or operate the lactic acid facility. Our parent company does on the biorefinery in Nebraska. Different than, say, what Total Energies Corbion has, where they buy their lactic acid from a third party, Corbion. So here and it may seem a small thing, but to any producer in the raw material space, it's much better flexibility when you have the whole system under one roof.
Okay, and does your sugar, is that a primary feedstock or a secondary generation feedstock?
It'll be what what would be called here primary. It's cane sugar, which is the abundant material right there locally. We'll be locating next to a sugar mill.
Okay. And will that have implications for your material here in Europe?
Implications in terms of?
Of that the European Union's latest revisions are asking for secondary feedstocks.
Yeah, that we had the preference expressed yesterday for secondary feedstock, meaning not the primary sugars expressed. Our take is that what really matters, and we've been saying this for many years, is not what the feedstock is, but the sustainability of that feedstock, and that we intend to assure using the well-understood Bon Sucre certification scheme, which goes all the way back to the farmer, tracks it forward, and makes sure the sustainable growing practice. So that's how we're going to address the sustainable ag questions. It's the analog to what we're doing with ISCC Plus for sustainable corn agriculture in the U.S. And really, I think for us, the question is often to us, why aren't you using a secondary feedstock, a lignocellulosic? And the answer to us is simply, why would you fight nature? Nature serves up for us in a sugar format, be it starch or sugar from sugar beet, sugar from sugar cane, something wonderfully easy to use. Why would you try to fight nature and use a lignocellulosic, a woody product that's used to build houses that survive hundreds of years, that grows trees that are hundreds of feet tall? That's a very robust structure designed to be tough and hard to break down. The implication is if you're going to use it, you're going to put a heck of a lot of energy into breaking it down. And so what matters is resource efficiency. You can put a lot of energy into breaking down a secondary cellulosic feedstock, and that has implications to planetary carbon, right? Or you can take what nature gives you, readily serves up, ready to use, a plain simple sugar that's easily used, easily digested. Why not go the easy route?
It's not good for us anyway, I've been told.
We all eat too much sugar, right?
That's correct.
Yeah.
I have just one more question, and that was your, what did you call them yesterday?
Competition.
Yeah, right.
Yeah.
Is also doing the chemical recycling of their PLA. Is this something that NatureWorks is considering at all?
It is indeed, and it's funny. Bo grabbed me from a discussion with our industry colleagues at TEC about exactly this topic, where much of what we just saw from Francois on chemical recycling, the ability to separate near infrared, it's the same data we generated 10 years ago, the same trials we've done, so we're of completely like mind that this is a great solution to recycle any PLA back to the building block. We've been doing it ourselves with our own plant off-grade to the tune of what are the numbers? Roughly 15,000 tons of PLA in aggregate. Since we built our facility 20 years ago, 15,000 tons have been chemically recycled back to lactic acid quietly and turned right back into polymer. We don't do it so much anymore because we don't make that much off-grade, and a couple of years ago we turned our attention, just like TotalEnergies Corbin, to how can we bring it back from the market. We actually got as far as establishing a bale spec, and just as Francois said today, we'd like to buy back PLA. We set up a bale spec in the US and said, if we can get our hands on a bale of PLA meeting this specification, this degree of contamination, we will buy it. And that offer still stands out there, but it's hard to get it going. In our case, it was going to be crushed cups. That's the big SKU, the big unit of probably the single biggest item in the U.S. is the humble, clear beer cup or cold cup.
Right.
That's what we were interested in.
From festivals or something.
Right. Yeah.
Right.
And we did quite a bit of work in Belgium. At closed loop festivals with cups specifically. Yeah. Cool buyback schemes or take-back schemes where every time a conference attendee would get 20 cups empty, take them back, they'd get a free beer, and that works remarkably well. So we incentivized the collection of cups, and it worked well.
Okay.
So we have the same thing. We haven't gotten quite as far as our colleagues at TotalEnergies Corbin to actually offer yet a recycled content grade. They're doing it by mass balance, which is a clever way to get things going. So yeah, we like what they're doing and talk about how we can do that collaboratively, because this is an industry issue.
Yeah.
Yeah.
Yeah. Well, maybe it's something that you could integrate into your sports alliance activities or something.
Yeah, we are having those
So-
conversations. Yeah,
Okay.
good.
Well, I'll look forward to hearing more about it then in the
Thank you.
future.
Yeah.
Thank you very much for your time.
Appreciate your interest. Thank you.
Thank you.